Section 14. Applications of conversions and rates. Here we look at the different geometric relationships and formulas. Example 1. Drew is planting grass, and the lawn is a rectangle that measures 120 feet by 75 feet. Drew uses 1 pound of grass seed for every 200 square feet. How much grass does Drew use? It's a rectangle. Length times width would be the area. We can rearrange and write down what we know. We know 120 feet by 75 feet. So we find the area must be 9,000 feet squared. He uses 1 pound for every 200 square feet. So we have 9,000 over 200. We find 45 pounds. Calculate the volume of the box with dimensions 3 feet by 4 feet by 36 inches. The problem is they're not all in the same unit, and they should be. Three feet by 4 feet by 36 inches. Let's convert that 36 into feet. 3 feet. That looks better. Let's find the volume. Length times width times height. 3 times 4 times 3. 36 feet cubed. Calculate the volume of a cylinder in cubic inches with a radius of 2.9 centimeters and a height of 0.35 yards. So the volume is pi r squared times h. We have an issue that we have 2 different units competing against each other. So I'm going to choose to convert yards first. I find that that's 12.6 inches. I can convert centimeters to inches. 1.14 inch. Plug this in my formula. Pi times 1.14 squared times 12.6, 51.6. Section 14 covers applications of items from Section 13, including area, volume, dosage, and CO2. When doing an area or volume problem, you must consider that the units are duplicates of themselves. Example, meters cubed or meters cubed indicate that the unit has 3 of the meters, not just 1. In order to cancel the 3 of the meter units, you need to have 3 fractions that can do this. Example 4. Convert 3,200 square centimeters into inches. So we start with what we're given. Let's convert. So we have to convert this twice because it's squared. So we divide by 2.54 twice. And we find 496 inches squared. Dosage calculations are another application of how rates can transform a medicine into the correct dosage for a patient. The most common method when we are given the weight of a patient as when given the medicine amount to be administered. Each problem we will want a dosage amount, whether that to be the total or per some amount of time, per 6 hours, per 12 hours, per day. That's very common, per day. Let's see what happens. Let's look at an example. The dosage of a certain drug calls for 15 milligrams per kilogram per day. It is divided into 2 dosage. 1 dose every 12 hours. If a person weighs 160 pounds, how much of a drug should he or she get of each dose? So we start with their weight. Always start with the patient's weight if that's something they give you. Let's convert that to kilograms since that's how it's administered. 15 milligrams per kilogram per day. 1 day, and they're going to do it 2 times per day. So we find 544 milligrams per dose.